All right, so what we're gonna do is we're gonna actually understand certain things. So first of all, we want to understand what is equation of tangent line, and in a correct form. So we want to use equation tangent line approximation. Now I will say this. When Isaac Newton around is 1650, back then there was no calculator. There is no decimals. There was no even like full function calculator. How are they approximate a value like say sine of 0.01 or sine of 0.1? The idea is they cannot. So you have to go with the approximation. They cannot evaluate a sine of 0.1. So what we propose idea is using equation tangent line, and why equation tangent line is very important. First of all, let's talk about equation tangent line is equal to y equal to y minus y1 equal to m times x minus x1. This is not equation tangent line. This is actually equation of a line of point slope form. It's that we change this m to, let's say, f prime of some type of c value. And we say this is x minus c, which is that particular c value. And then it's going to be y minus f of c. Now, if you realize this is just a different format of equation tangent equation of a line. It's just in terms of calculus. Now, what is interesting thing is if you type this into the graphing calculator, and because the way you assign a variable, now we can draw equation tangent line at any given points. So I'm trying to say this. Let's show you. Get rid of this. Get rid of this. Get rid of this. Get rid of this. Okay. Add a value c slider, and go in here. Do you see that I type in y minus f of c equal to f prime of c of x minus c? Now, if I just play the slider, this is going to be equation tangent line at any specific x value. Like x can change, depending on the c changes. So that is going to be your equation of tangent line at any given point. Now, let's just say c is equal to 0. Right? What's interesting thing is, well, let's just say I want to approximate at 0.2. According to the decimal, is 1.198. And the 1.099 if when x equal to 0.1. But we also have equation tangent line. At a closer value, it's gonna be pretty accurate. If you look at this, see the blue line is basically on top of the red line, right? In a small thing, if I'm zooming more, I'm still seeing exact same thing. It's pretty accurate even till this point. Now you see this point is a little bit deviated now. The blue line is a little bit over the red line, right? And gets larger when you zoom in enough. But when you go into somewhere closer to the next value, you have to zoom in a lot more to get to see the difference. And if you go to 0.01, this point, you have to keep on zooming. And it's only to the thousands you see that, okay, there was small minuscule difference. And usually that minuscule difference is negligible. Remember, this is 300 years ago, 400 years ago at 1650s when Newton invented calculus. They have to discover those value. They want to calculate those specific value. They need the accuracy to the hundreds place, to thousands place. Even in hundreds place is pretty good already. Okay, so what we're gonna do is we propose that using equation tangent line, and we're trying to approximate value and see how much of the big difference is. According to this table, this is the actual value. That's it. Now, can we use equation tangent line? So we are talking about y equal to 1 plus sine of x. Okay, so we're gonna say f of x equal to that. And we're gonna say we're gonna approximate when x equal to 0.2, x equal to 0.1, and x equal to 0.01. We're gonna approximate. See how hard is it? Now, equation tangent line, what do I have to do? I have to take what? Derivative. So if I take a derivative, what am I gonna get? F prime of x equal to cosine of x. And once you take a derivative at cosine of x, and then you say, okay, well, that's good. I'm going to plug in 0 because that's the value is really close to 0. So we're going to plug in 0. So it'll be cosine of 0, which is what? 1, right? If I plug in 0 here, it will be 0 comma what? 1, right? So it'll be y minus 1 equal to 1 times x minus 0. Y equal to x plus 1. This is my tangent line approximation. This is my tangent line approximation. Y equal to x plus 1. Now, what happens if I plug in 0.2? Well, when x equal to 0.2, then it's going to be 1.2, right? When x equal to 0.1, then 1.1. When x equal to 0.01, it's going to be 1.01. So this is my approximation. Now, compared to actual value, let's see. 1.1928 compared to 1.2. It's about in the thousands difference. It's two thousands. It's pretty accurate without calculator. And we're talking about 0.2 is very far away from 0. If we get closer than 0.1, then according to our approximation is 1.1. Then here is this 1/1000th place because it's pretty accurate compared to that small situation. Now, if you go to 0.01, we are almost at 8 decimal places accuracy because our approximation is 1.01 and this one's 1.0099999. So we're talking about almost 6 decimal places to 7 decimal places accuracy. We're doing pretty good accuracy within at 0.01. So this is pretty accurate. Is that okay? Now, one thing I want to talk about is I didn't talk about in BC Calc actually, so separate you need to pay attention. Is the differential. Like, what is differential? Differential is super easy. Like, everybody here, even you have the worst grade, you can probably do differential. It's pretty easy. Is imagine that if you have y equal to x squared, dy dx is equal to 2x, right? The differential is actually dy equal to 2x dx. Just move the dx to the other side. Just move the dx to the other side. Okay. What happened to y equal to x squared plus, no, square root x plus sine of x? But guess what? If I take a derivative, dy dx is what? 1/2 x to the negative 1/2 Is that okay? Plus cosine of x. And the differential is going to be dy equal to 1/2 1 square root x plus cosine of x in the dx. And now dx is the small change of x. So now everybody know how to do differential. Now, let's go back to 1650. Isaac Newton says, hey, I really needed this value because I need to calculate the speed of a planet or whatever. And I really need this value, 16.5. Square root of 16.5. I need you to approximate this value. Because back then we don't have a calculator, we don't have a calculator, just do 16.5 and square root. And we can get a decimal all the way to 9 decimal places. But back then you don't need a 9 decimal places accuracy. You needed somewhat like 3 decimal accuracy. Can you approximate this? If you were to approximate, what do you think is going to be, Sam? Like 4.2, okay. Emily, what do you think?
I was thinking around the same, like 4.2 because we have to be slightly higher than 4. We got 16, we approximate from there.
Okay. Emma, what do you think? 4.3. Okay. You want to be different. You want to say, yeah, I think it's 4.3. Jacob?
4.25.
4.25? Did you use calculator?
Oh, I didn't use calc.
Okay, you didn't. Okay, all right.
I didn't calc.
Okay, 4.25. Fabian, what do you think?
Yeah, I like that. 4.25.
Fabian, stop being follower. You cannot follow the white people. They're evil.
Yeah, I got it.
Especially, no, I'm just kidding. I'm going to say something else. It's going to be like,
Watching.
Ben Shapiro is going to say,
I think it'd be like 4.267.
5 points. What?
4.267.
4.627. Okay, Max. 4.15. Okay, we don't know. Now, what we're gonna do is we're gonna take this. For who? Okay. So what we're gonna do is we're gonna assume a function. Which function would like to assume to approximate y equal to square root of 16.5? What? Square root of x is a good idea because that was the function, square root of x, right? And we're gonna call this y equal to square root of x. Can we do a differential on this? Okay, just take a derivative. So that's going to be dy over dx equal to 1/2 x to the negative 1/2. Is that okay? Dx. Oops, not dx yet. So I'm moving the dx to the other side. So 1/2 square root x dx. Now you're going to say, what is dy and what is dx? Dx is that small changing of x. Dy is that small changing of y that we are affecting. So the common situation is every one of you guys have told me that the approximation is roughly 4 point something. Because you guys know what is square root of 16. Is that okay? Square root of 16 is a known value. Then that's equal to 4. We know that. So we're going to base on that value. We're going to base on that. We're going to base on 16. Why we base on 16? Because we know square root of 16. Now you're going to say, well, what is dy then? So y/2 square root of 16. Now what's the dx in this case? y.5. That's the change, right? That's change of 0.5, right? So that's equal to 1 over 2 times 1 over 4 times 0.5 is 1/2. So that would be 1 over 16. So that's the small changing of y. Now changing from what? Changing from what? Square root of 16, right? Square root of 16 is 4 plus 1 over 16. That's equal to what? 65 over 16. And I'm going to type in the calculator. I'm going to say 65 over 16 is equal to 4.0625. And all you guys are over approximate by a lot because people say it's 4.2. People say 4.3. People, I forgot what Lee says.
4.267.
4.267, right? Your approximation is gonna be off just slightly. Some people even say like bigger value than this. Are you serious?
That's where you keep your min.
That look really sus. Hold on, can I take a picture of this? Report it to a safe.
They told me if they catch me with that, they're gonna give me a 10-day referral. So I put my meds in my Android box. If they catch me, they'll just tell me.
Yeah.
Amphetamine, 20 milligrams.
Oh.
Yeah. I don't know what happened to my computer. I think I need to reset my computer. It froze?
Yeah.
When did it froze?
Well, wait, I think it's stuck on that. When you're talking about the graph. Oh, what?
Ah, it did. Hold on. Let's say N. No, let's say get rid of this. What does it cost that though?
They make you like put on like something.
You're mentee. Maybe.
What do you think it makes that? Is my memory small or what?
I wouldn't think it would be that. What do you think, Lee?
I think when the thing pops up about like, oh,
Those happened before that.
really? Okay.
I was too scared to say anything.
Hold on, I had problems with this thing last year.
Okay, so 4.0625. And what's my actual approximation? Let's go look at the actual approximation for square root of 16.5. It's a 4.62062. We are in we're saying it's 65 over 64. Sorry, 65 over 16. Sorry. It's a 4.062, so it's pretty accurate in only to 5,000th accuracy. It's a very good accuracy for able to approximate 16.5. The closer the value, the more accuracy the value. If you approximate 16.2, it's gonna be way more accurate than 16.5 because the more closer to the known value. Does that make sense? Okay, so basically this what is going to be, and then you say, okay, well I want you to approximate cube root of 7.8. Cube root of 7.8. Now I want to show you equation tangent line. Give me a second. Let me show you equation tangent line. Because we know at 16 it's going to be 4, so it'll be y minus 4 equal to x minus 16. Is that okay? And the slope is gonna be, I'm gonna plug in 16 here, so it's gonna be slope is gonna be 1/2 times 1 over 4, so it'd be 1 over 8. So it'd be 1 over 8. Is that okay? This is equation tangent line. if I were to approximate 16.5, that means I'm gonna replace this with 16.5. So that's equal to 1 over 8 times 16.5 minus 16, y minus 4. This is the dx. Do you see that? 16.5 minus 16 is the dx, right? The whole thing is the dy. So therefore, it's going to be y minus 4 equal to 1/8 times 1/2, which is 1/16. Y minus 4 equal to 1 over 16. And move the 4 over, so it'll be 4 plus 1 over 16. So it's 65 over 64. Which is, that's a very, very good approximation. So I want you to approximate this and also set up a little bit of trap.
7.8.
Yeah, Q rule 7.8. And for math computation problem, they usually will ask you to approximate, let's say, sine of 32 degrees. But it's not hard if you think about it. Sine 32 degrees.
We just sign up.
It's how different the value is to the known value. Known value is square root of 16. 0.5 is change from that original value that we're trying to approximate. Right?
Samuel sound pretty smart.
I'm locking in.
Sound intelligent.
I gotta make a for optimization and graphic.
Well, when are we gonna grade that thing?
What?
When are we grading that thing?
You're gonna grade them.
I'm gonna grade it?
Get your Adderall, man. You're gonna.
Alright. I'll grade the
The end
whole.
of the recess paper.
I'll grade the whole school
He's not grading
just
my
to grade
paper.
her paper.
He's not grading
I'll
my
grade the
paper.
whole school's paper just to grade her paper.
We're not grading my paper.
Watch, bro.
The hate between the middle.
The revenge is gonna be my revenge is gonna be beautiful. That's gonna be nice, bro. Just be proud of me.
Bro, I wasn't here.
Like, you don't need to be here to stick my name.
That's what you did.
It's swear word, bro. You learned that in 5th grade.
Is it meant to be 65 over 60? Is it meant to be 65 over 64? The end of 65 over 60?
Oh, 60, oh. 16, yeah, 16.
Okay, well,
Let me think about it.
Yeah, I read on 16 before. Sepper, you're gonna approximate sine of 32 degrees. You gotta prove it on team 0. You and Jesus are team 0.
Oh, we need me and Susan Aiden on team 0 Wednesday. That would be a golden team.
I think that would be a good team.
I genuinely think that would be a really good team. I'm not even lying.
I generally think like you guys have a very good intuition.
We could just put our minds together and like get it to work.
But except you and Aiden will be yelling at each other.
I'll start yelling at Aiden, calling him.
I'm gonna put you guys on the team.
That'd be funny. That'd be just funny to watch. You can just do that shit. That is like sitting there and watching us.
Hey, I'm telling you, it should solve that problem like this. Not
I'll solve it too, man. Let me just give me some time. I got it, Mr. Like,
he did it in 5 minutes.
bro, no, I will do it. Time is not a matter, Mr. Solving it is the point.
It's just how.
1 divided by half.
Just live there. Just live there.
I was like, what?
You just.
60 is
That is y minus 2.
Watch out for the DX.
I just thought
Did I do the first?
So y equal to x to the 1/3. Is that okay? dy is equal to 1/3 x to the negative 2/3 dx. That basically move the dx to the other side. That's the differential. Now we know the value of q root of 8, which is 2. So we can say it's 1/3 times what? 8 to the negative 2/3. And dx is what? Negative 0.2. Not positive. Because there is small difference of d2. It's going to be less. It's going to reduce that value. So it'll be 1/3 times 1/4 times negative 1/5. So it'll be negative 1/60.
Wait, why?
It's 7.8 to 8.
Oh,
So therefore, it's going to be the known value minus 1/60. So it'll be 1/19/60. You can see they are very accurate. They're very, very, very accurate. Yeah?
Why is it, yeah, why is it 2 minus, why is it not 8?
It's not big because you know what q root of 8. So let's just say if I do equation tension line approximation, right? We know 8 comma 2 is the function. So because y equal to cube root of x, if I plug in 8, I'm going to get 2, right? So let's just say dy dx equal to 1/3 x to the negative 2/3. And I plug in 8, so 1/3 8 to the negative 2/3 is equal to 1/3 times 1/4, that's equal to 1/12. And then 1/12 is going to be your slope. So y minus 2 is equal to 1/12 times x minus 8. Remember, I show you 7.8 is right here. Then it's going to be 1/12 times 7.8 minus 8, which is 1/12 times 0.2 negative, which is the dx. Do you see this is dx? And this is the dy. And this is 1/12 times 1/5 negative. So it'll be 1/60. But y minus 2. So you got to move 2 to the other side. So 2 plus 1/60. So that's also equal to 60. No, this is minus. Thank you. This is also 1/19/60, which is a very, very, very accurate approximation if you really look at it.
There's 2 ways to solve it.
On AP exam, they want you to use equation tangent line. I just show you in terms of differential, but they are the same thing.
if I do it as a differential, is it negative 1/60?
It's fine.
Yeah.
I think that will look cool.
I think they will say tangent approximation. Just find the tangent line and just plug in the value. That's actually very, very straightforward. You had to don't think had to think about anything. So I'll probably use equation tangent line more on AP exam because they will literally says use the equation tangent line approximation to approximate this. And this is what you're gonna do. Okay, let's talk about ping pong ball. I have a 2 ping pong ball here. Simple question from the manufacturer perspective. For the manufacturer perspective, is this ping pong ball exactly the same? It's not possible to be exactly the same. There's no machinery can make exactly the same. There's probably a very small difference. But long as that difference is within our margin of error, that we can say that's negligible. Not just say that small difference is something that we cannot see. What we cannot see is maybe we can see centimeter, right? We can see millimeter, but it's really hard to see it's 1/10 of millimeter. 1/10 of millimeter is our eyes cannot perceive. That's less than a hair. Like one hair string, depending on which hairs we are looking at. Some hair is bigger than the other one, but that hair is probably like I would say probably like 0.2 millimeter. Um, and that's very, very small. But a ping pong ball, it has a diameter of 40 mm, which is millimeter, which is also known as 4 centimeter. Now, if each of the ping pong ball, they are manufactured to be exactly like this. They can try, but there is always like there's small error with it. Not just say the error is within 0.01 centimeter radius. Okay. Do you know how much effective value if you have 0.05, 0.01? The radius. Yeah. How much does it affect the value? How much of the volume will change if you have 0.05? So put your computer away, Jacob. So we know the volume of this ping pong ball is a 4/3 pi r cube. Is that okay? And we know the r is somewhere that it have a margin error of 0.01 centimeter. Because we cannot see that. We cannot see that. There's no way that we can see 0. Wait, 1 centimeter has 10 millimeter, and 10 millimeter, each 10 millimeter has a less. King Henry died by drinking chocolate milk. King... What?
Chocolate coffee creamer.
Chocolate milk. Well, milk is the smallest one. What's after millimeter? No, nanometer times 10 to the negative 9. That's 10 to the negative 10.
Macro? No, macro's big. Micro?
That's no, I don't know. Anyway, huh? Google.
Google me.
No.
That's like the biggest, like.
That's one of the biggest numbers. All right. So now, if I would take so the question is how much volume is impacted. If I have 0.01 centimeter radius difference, how much volume is impacted? Well, we can take a differential and look it up. So that's going to be 4 pi r squared dr, right? And we just see the 4 pi. Well, we know the ping pong ball is r equal to 2 for ping pong. 2 centimeter because they have diameter of 40 millimeter. Yeah, which is 4 centimeter. Yeah, but the radius is 2. So it'll be 2 squared dr. dr is going to be a plus minus 0.01 centimeter, right? So therefore, it's 16 pi times plus minus 0.01 centimeter, and that's equal to 0.16 pi centimeter cube. So that's centimeter cube. This is a centimeter square. And this is centimeter cube. So that's how much volume impacted. Even you have 0.01. So you might say like radius is not a big deal, but if you have one small change in radius, it's going to impact bigger on the volume. And how much a difference? It was going to be affecting 0.16 pi of centimeter cube. Yes?
Why don't you write plus or minus 0.16?
You should. You're right. And it's plus minus because sometimes you have errors bigger, sometimes you have errors smaller, and that's how much it impact. Now, this is known as a propagate error. So the propagate error, the propagate is, what's one thing impacted the other one, right? So the radius change impact the volume change. And this is how much the volume is going to estimate to have change. Now, you're going to say, well, how do I figure out percent error or relative error? So what is relative error? Relative error is going to be the changing of value over the total value. So this equal to a relative error because you compare to the original value over the small error. So therefore, you can take the dv, which is dv is going to be 4 pi r squared dr. And this is 4 over third pi r cubed. If you simplify that r squared and r cubed, and you simplify the pi cancel out, that will give you 3 dr over r. If I simplify everything. And that's going to be 3 times 0.01 over r is going to be 2. So it'll be 0.03 over 2. I have no idea what is that. 0.03 over 2 is 0.015. This is a relative error. It's relative to the original value. Now, what will be a percentage error? It's going to be moved 2 decimal places, so it'll be 1.5% error. This is called a percent error. Percent error. Which is 1.5%. It's negligible. It's not very, very large. But the ball bearing inside the machinery, they can withstand the 0.01. Okay, yes.
Where did you get volume?
What did I get? What?
Volume.
Volume? I don't need to calculate. I just simplify the volume. Volume is 4 third pi r cubed is a volume of sphere. That's radius of a ping pong ball.
The answer 1 minus whatever the 3 times sine of 2 over 2.
I don't know. I didn't do it.
I need to calculate the sine of 2.
You need to convert a degree to radians.
I did. It's pi over 90.
I think if you got that, you got it.
It is good thinking about it. That's how you think.
Cosine of x dx, right? And we say it's 30 degrees, right?
Yeah.
So cosine of 30 degree is what?
Wait,
You just gotta think about it. Think about it.
square root of 3 over 2. No,
What
I
if-
got it right. It's the square root of 3 over 2. I read it.
Square root
Sine
of
of 30.
dx is gonna be pi over 90, right? Then that's gonna be
Wait, why isn't it sine of pi over 90?
Where did pi over 90 come from?
what?
Why isn't it sine of
So we're trying to approximate sine of 32 degrees. So the dx is gonna be pi over 90, and then cosine of 30 is gonna be square root of 3 over 2. So that is gonna be square root of 3 pi over 180. Is that okay? And you have to figure out what is sine of 30 degrees. Sine of 30 degrees is 1/2. So it's gonna be 1/2 plus square root of 3 pi over 180.
Why isn't it sine of pi over 90?
Differentials.
Because isn't the difference between those two the sine of pi over 90?
Pi over 90 is the dx. This is how much you change degree compared to we know.
Yeah, I got it wrong. Nah, never mind.
About it.
It's her fault, bro. It's literally
I
her.
was in the rest
She is literally on the hater.
Larissa beat I beat Larissa.
I beat for Larissa.
All of us.
Nah.
And we had speaking with somebody squad.
kick them out.
What?
If we kick them in, I'm looking at these people.
What? Yeah, how'd it go? I heard it was just like a flash and then you're done. I didn't even smile. No, I literally had teacher swap day.
What are you swapping with?
Next summer.
You know how to teach European history?
Oh yeah, I got a class.
Cancel out. You there. The whole time. You cancel out, dude.
Go away.
Google says that you might need to update your Mac, your settings. Because it's outdated graphics, possibly.
You what?
It's saying it's outdated graphics, which could be solved just by updating your computer. So if Mac has a new update or something. But that might take a while.
What's update?
Can I
How's
get
my
a,
update?
can I get a,
Like, I didn't even choose the picture.
Yeah,